Well, welcome back. Thanks for joining me again on my second discussion on Chapter 6, Time Value of Money, along with my teaching notes. In this discussion, we're going to cover the future value of a single amount. The idea here is to learn how to value a single cash flow, not a stream of payments. There's $1, and the question is, how much will $1 grow to be if deposited for 4 years in an account somewhere, earning shouldn't have happened, earning 10% for 4 periods. So how much will $1 grow to be in 4 years at 10%? This diagram will often help you to see it, and I'm trying to see how we get from here to here. We said you could learn to do it 2 different ways, if you recall. One by hand with successive interest computations. Kind of a bummer, but this is how it would work. Take the $1, grow it by 10%, $1.10. Take the $1.10, grow it by 10%, $1.21. If you're wondering why I have 1.10, the 1 keeps the base intact, growing it by 10%. $1.21 growing by 1%, 10% again. $1.33 and some change. $1.33 times 10% will give you $1.46. So you could answer $1 would grow to be $1.46 after 4 years at 10%, and you could prove that with a successive interest computation. You could also compute this, or compare this, I'd like you to, with the chart on Table 1. Table 1 tells you, for Pete's sake, Table 1 tells you how much $1 would grow to be after 4 years if invested at 10%, and the table says 1.4644 if you look at the arrow. So the second one would be to look at the table. What I want you to notice about this table is if I back up, $1 for 1 year at 10% is 1.10. 1.21 is the second table. 1.33 is the third table. 1.46 is the fourth table. Some poor fool had to sit down and grow $1 for all those periods, compounding it once a year. How would you like to have made that table? Yee! Second way to solve this would be by using the formula, and we said we're not going to do that. We're going to just say we did. The third way you could solve it, which is one we're going to use all the time, is to take the present value, your $1, and times it by the interest factor from Table 4, where n equals 4 and I equals 10%. I said Table 4, I meant Table 1. So go to Table 1, find the interest factor for n equals 4, read across till you hit 10%, it's 1.4644, and the $1 times 1.4644 equals $1.46. You could also do this using your calculator. Calculate the amount using the time value of money functions on your calculator. Enter $1 as the present value, n equals 4 and I equals 10, and solve for the future value. Make sure that you empty all the registers on your calculator before you do that, and if you do that, you will find your calculator gives you the amazing number of 1.46. So we could do it by solving with successive interest computations. We could do it by solving with the formula but decided we didn't want to. And we could do it by using the charts or the interest table. This was Table 1 from your book. Well, if that table was made with $1, it will work with any amounts of dollars because it's an interest factor per dollar. So then you could answer very easily, how much will $5,000 grow to be in 4 years at 10%? You could take the long way of answering this by building a fund accumulation schedule. I've added the first few rows for you. Take 5,000, times it by 10%, and then add that on. 5,500, you could times it by 1.10, and it'd be be shorter. Take the 5,500, grow it by 5%. 10%, sorry, 1.10. Grows to be 6,050. Now I want you to finish it. How'd you do? I came up with 7320. I know you could say there's a rounding error, but one thing we have to promise each other is not to let $1 rounding errors drive us crazy this semester. So there you go. There's your fund accumulation schedule approach. You could solve it in a much easier fashion using the interest table 6-1 by taking 5,000 and timesing it by the interest factor on n equals 4 and I equals 10, which you know was 1.4641. We saw it on our last table. 5,000 times 1.4641 equals 7320. Same answer. And now do me a favor, seriously, and take a moment and solve this with your time value of money calculator. What you do is clear the registers, enter a $5,000 present value, n equals 4, I equals 10%, and then solve for the future value. Go ahead and do that. And here's a very cool answer. Using your time value of money calculator, you get the same number. So you have 3 ways you can do this. 1, you can do successive interest computations, making a fund accumulation schedule. 2, you can solve by using the interest tables. And 3, you can compute the amount with your time value of money calculator. Students should be able to do all 3 of these. What would the journal entries look like for something like this? Let's say you're making a savings account. I guess I better put a T there, huh? The resulting journal entries would be, the first journal entry would be to make a deposit in the savings account, debit savings account, credit cash for $5,000. And you'll recall the first interest at the end of the first year was $500. So put that in your savings account and credit interest revenue. And on the third year, you would earn or the second year, $550, the end of it, interest revenue. And the third year, $605, and the fourth year, $665. So I have a question for you. How much total interest would you earn? You could come up with that 2 different ways. 1, you could add up the column, and that would equal $2,320. Or you could take a logical shortcut. Work with me on this. If you end up with $7,320 in the end, and you put in a total of $5,000, how much was your total interest? And 5,000 minus, or 7,320, your ending balance minus 5,000 is going to give you the same number, $2,320. Oh, for Pete's sake, $2,320 of total interest. So you could add these numbers up. That would work. Or you could say, well, I started here and I ended here, so I must have earned this much interest. Both of them work. One's just a little faster than the other. You should look at pages 323 and 24 in your book now, and you'll see your author didn't cover this in as much detail as Lynette did. But I kind of like my approach. And if you're thinking, geez, this is easy, then I must be doing something right. That concludes my second discussion on the future value of $1 in my second video on time value of money, chapter 6. Thanks so much for joining me. Talk to you soon.